Welcome to Cognito Key. Have you ever looked up at that big, bright sun and just wondered, how on earth can we capture all that power? Well, in today's explainer, we're going to do exactly that. We're going to break down the amazing science of solar panels, turning pure sunlight directly into electricity. So here's our game plan. We're going to follow the incredible journey of energy, starting with just one tiny particle of light. Then we'll look at how a solar cell is cleverly built to grab it. And finally, we'll see how all these pieces come together to create a system powerful enough to light up our entire world. Let's get into it. All right, so everything, and I mean everything, kicks off with the sun itself. And there's this fundamental secret of physics that makes this whole thing possible. It's actually a beautifully simple idea that scientists have figured out how to harness. So what's this special little device at the heart of every single solar panel? It's called a photovoltaic cell. You'll probably hear it called a PV cell for short. Now, the name itself is a fantastic clue, right? Photo means light, and voltaic has to do with electricity. It's a device designed to do one pretty incredible thing: turn light straight into power. The whole process begins with these tiny, invisible little packets of energy called photons. You can think of them as little messengers making the long journey from the sun. Billions and billions of them are hitting every square meter of our planet every single second. Just imagine that, carrying the sun's energy over 150 million kilometers of space just to get here. Now here is where the real magic happens. When one of these photons, carrying just the right amount of energy, slams into a special material, it can literally knock an electron right out of its spot, setting it free. This is called the photoelectric effect. And it's that fundamental spark, that little push, that makes all solar power possible. Okay, so we've got these electrons that have been set free. But, a bunch of free electrons isn't very useful on its own. How do we control them and turn them into electricity we can actually use? Well, we need to build a very special device, because you can't just use any old material. This requires a very specific and, frankly, very clever design. The secret sauce here is a group of materials called semiconductors. And you've definitely heard of the most common one, silicon. It's used in almost all panels today. Now, what makes them so special? Well, they're not amazing conductors like copper, but they're not great insulators like rubber either. They're kind of right in that sweet spot in the middle, which gives us the perfect ability to control the flow of those energized electrons. So to really make the magic happen, we take this silicon and create what is basically an electrical sandwich. We make two slightly different layers. One layer, the N-type, has a few extra electrons hanging around, and the other layer, the P-type, is missing a few. Now, where these two layers meet, they form this really important barrier. It's called a p-n junction. And that junction, that's the absolute key to this entire process. This special layered structure is basically what directs the flow of electricity. You can think of it like a perfectly designed one-way street, but just for electrons. So let's walk through exactly how it works, step by step. It's a really simple but totally brilliant three-step dance. First, a photon from the sun strikes the cell and gets absorbed right near that p-n junction. Second, this jolt of energy knocks an electron loose, setting it in motion. And third, and this is the crucial part, a built-in electric field at the junction acts like a slide, forcing all those loose electrons to travel in the same direction. And what do you call a flow of electrons? That's an electric current. And just like that, we've created a flow of electricity from pure sunlight. How amazing is that? But, there is a catch. A single solar cell, well, it's not very powerful all by itself. Actually, a single cell is surprisingly weak. On average, it only produces about 0.6 volts of electrical pressure. I mean, that's not even enough to power a small toy, let alone something like your toaster. So we clearly need a way to boost that power up. So, how do we get more power? Well, we team them up, just like you do with batteries. We can connect the cells in a line, which is called a series connection. That adds their voltages together and gives us more electrical push. Or we can connect them side by side, in parallel, which adds their currents together for more electrical flow. But why choose one when you can have the best of both worlds, right? Solar panels use a really clever hybrid approach. They connect groups of cells in series to build up a really high voltage, and then they connect all those groups in parallel to build up a really strong current. This series parallel combination is the secret that turns dozens of tiny weak cells into one seriously powerful solar panel. Okay, so now we have a powerful panel that can generate a good amount of electricity. But that panel is actually just one piece of the puzzle. Let's look at the final step, putting all that power to work in a complete, usable system. First things first, you want to make sure you're always facing the sun to get the maximum power, right? Well, that is the job of a maximum power point tracker, or MPPT. It's a really smart system that physically tilts the panels throughout the day, literally following the sun's path across the sky to squeeze out every single last drop of energy. Next up, you need a bodyguard for your batteries, because on a really bright day, the panels can produce a huge surge of power. The charge controller acts as a safety valve. It carefully manages the flow of electricity to make sure your batteries don't get overcharged. This protects them from damage and makes them last a whole lot longer. And finally, there's one last absolutely essential conversion that needs to happen. See, solar panels produce a type of electricity called direct current, or DC, but our homes and all our appliances run on a different type, alternating current, or AC. The inverter is the vital piece of equipment that makes that switch, transforming the raw solar power into the clean, stable electricity your home can actually use. And there you have it, from a single photon traveling across the vastness of space to the free-flowing electrons inside a silicon sandwich, all the way to a complete system powering our daily lives. The really key thing to take away is how this powerful, complex technology is built on such simple, elegant principles of physics. It really makes you wonder, doesn't it? Now that we've learned to harness invisible light, what other invisible forces all around us could be harnessed for energy next? Thank you so much for joining us on Cognito Key. If you found this explainer helpful and learned something new, please do hit that like button and share it around. And of course, don't forget to subscribe for more deep dives into the amazing world of science and technology.